Morning everybody. Today we're going to look at the second lesson in probability. And we're going to start asking the question, how often would an event happen? Now many of you will know that I have a rather naughty cat and a very kind dog. So we're going to look at what happens between Fendi and Bonzo. So let's just draw something out for you first. Let's consider what's happening with my Bonzo and my Fendi. Now, over the week, I looked at how many times my dog was being unkind to my cat, and I did a tally chart, and these are the results of my tally chart. So if you look carefully, you can see how many times Bonzo was being unkind to Fendi. So on Monday, there were 2 occasions. On Tuesday, there were 7. Then there were 4. Then there were 2, 8, and 5. How often do you think he will be unkind to Fendi on Sunday? That's my question. How often do you think it will be there? Now, in order to answer this question, there are 2 things you can do here. One idea is to work out, well, what is the average number of times he's unkind? That will give me an idea of how many times we think he might be bullying Fendi on Sunday. So if I count all this up together, I get to 30. Share that by the 6 days, and that gives me an average of 5. So I predict that maybe 5 times he will be nasty to my lovely little dog. But let's look at that data even further, because that is one way of doing it. But there's more information here. So I'm going to look at it slightly differently, and I'm going to look at the trend of what might be happening. So let's look at the trend and see if this will tell us any information. So what you can see here is actually that Bonzo sometimes goes crazy and sometimes doesn't. So we get a trend here, and you can see that it's slightly moving up. So if I consider it, it's probably going to be around here. So then I can predict that it will be not 5, as this would suggest, but maybe 3. So in looking at how often an event will happen, we use data in order to give us predictions. And from those predictions, we can get probabilities. So what we're going to look at today is 2 types of probabilities. We're going to consider the theoretical, and we're going to consider the experimental. So we have the theoretical and the experimental probabilities. Now, let's consider what is experimental and what is theoretical. For this, I want to introduce 2 characters. So what we have here is the theoretical. So this is what we establish as being what happen in theory to events, as opposed to experimental. So with experimental, let's introduce our character. So we have 2 types. We have the theoretical and the experimental. Like I said, with the theoretical, if we want to see about this dice, is it fair? Is my dice fair? Now, we don't say fair. What word do we use? Biased. So is it not fair? Is it biased? Is it going to give me more of a number than it does any other numbers? They're going to occur more times. So in the theoretical, what we need to do is we need to consider 2 things. The number of outcomes and the number of successes. So for here, I look at the number of successes, and we did this last lesson, all over the total number of outcomes. So if I want to say, what's the probability of my dice getting a 4, I would say that on my dice, I have 1 4, so 1 success out of 6 possibles. So in theory, the theoretical probability is going to be 1 in 6. Now, what about the experimental? Let's consider the experimental. Now, how am I going to do that? Well, let's see. I'm going to do an experiment. So what I'm going to do is I'm going to roll this dice 60 times, and I'm going to see how many times I get a 4. So what I can see here, if I count all this up, I have 10, 20 here. This is my total. I have 20 here, 10, 20, 30, 40 here. So according to my experiment one, the probability of getting a 4. So let's just see here, the probability of getting a 4. Now this is going to be the total number of occurrences, how many times something occurs, over the total number of trials. So that's how I measure for experimental probability. This one is for theoretical, how many outcomes, and I can use things like space properties, space diagrams, and various things like that, which we'll talk about later. But in this one, it's about the number of trials. So if I look at this, I can say that I have 20 times it occurred as a 4 out of 60. That's the total number of trials I did. And then I can simplify that. I'm keeping it to 6. That's 2 out of 6. Now my question is, in theory, I should get 1 over 6. In practice, I got 2 over 6. Question is my dice biased?